Hello everyone, and welcome back to the GIS 302 sample presentation. In this sample presentation, I'm going to go through what I would consider to be a reasonable approach to the presentation. When I'm giving the presentation, I want you to look at three things, because these are going to be the three sort of grading criteria. One is going to be the length. The video should hit somewhere between 5 and 10 minutes. I would imagine it's going to come out to about 7. The second is going to be the overall style. And what I mean by that is generally you want the pictures or the figures to be large and clearly visible, and you want your text to be legible and not overwhelming. So you'll see that I typically have less than 15 words on a slide, and they tend to be in bullet point form, and I tend to expand on what's on the slide with words. Right? I don't write everything out on the slide. The third is going to be how you set up your information. And so what I mean by that is, as I go through the presentation, hopefully you'll notice that what I'm focusing on, because this is a remote sensing course, is the remote sensing side. So you'll see that I'll throw in a couple of introductory slides talking about the problem and some of the environmental issues, but I spend the vast majority of the time breaking down the remote sensing, looking at the figures, explaining how the figures were created in terms of what the imagery was used and what they did, and explaining what the figures actually show and trying to interpret those results. Right? Because that's the stuff that, after having gone through this course, I would really hope that if you spend a couple minutes grappling with it, you should really be able to understand what they did. And if it's a technique you're not familiar with, by all means, please reach out, because we can't cover everything in the course. So with all that being said, again, just to recap, the things I'm looking for: how you handle the information, the overall quality of your presentation, and the overall length of your presentation. So that being said, let's go ahead and look at the example. Hello everyone, and welcome to the GIS 302 sample presentation. My name is John Gross, and in this presentation I will be giving a brief overview of monitoring vegetation change over time. So the study area for this particular piece of research was a region in Kentucky which had two different sites, an area of active management and an area of active deforestation. And the reason that this study site was chosen is because Kentucky was estimated to have lost about 100 acres per day between the two time periods involved. And this is important because we can see that losses due in part to mining and logging practices, as well as natural impacts such as climate change. Now, some of these changes result in a positive change in vegetation, but these are largely due to grasses and shrubs and not forests, where we see the original ecosystem. Remote sensing is extremely useful because it's actually one of the best ways to obtain quick and reliable measurements in these complex ecosystems, and it also provides an image archive to be able to go back and do these sorts of time series detections. So this image right here, this is actually a land cover data from 2006, and we can see that the forested areas are in green, whereas the red and yellow represent human land use, so urban areas and farming areas. You can also see that there are these brownish patches here, right? These are typically bare soil or grassland. So you can see that the majority of the Kentucky landscape is actually supposed to be dominated by forest. And when we have deforestation, right, we're taking that forest away, and then even if it does come back, it generally does not come back as that original forest. So this is a really big issue, just to understand how, and more importantly, where the landscapes are changing. So as I mentioned previously, this specific study had two study areas located in that region of Kentucky. The first here is Site A, and the second here is Site B. So you can see that they both look similar. Site A, they're actively deforesting, so this actually is an expanding region of mining practices and logging practices. Whereas Site B here is actually being managed, so they're trying to recuperate the forest. So this is actually a contracting area, right? Expanding, contracting. So these two study areas are going to be sort of the comparison. So we're going to look at how this site changed over time, and we're going to look at how this site changed over time. And we're hoping that by doing so, we'll be able to see this area gain vegetation, and this area, I shouldn't say hopefully, but this area will likely show increases in deforestation. So let's talk about how they actually went about handling this from a remote sensing perspective. So the study actually used a two-pronged remote sensing approach. The first is just a simple visual investigation, so looking at high-resolution imagery, comparing time 1 to time 2. And the second one is going to be some actual mathematical difference in change detection. So this is going to be that image differencing approach. And so you can see here, based on this is a snippet of the results, that they compared 2008 to 2005. Comparing NDVI was one of their change detection approaches. And you can already see here we have very strong differences between site A and site B. And you can see at time 1, right, the difference between site A and site B. So let's go ahead and take a look at the actual imagery that was used. So for the visual investigation, right, you need to have something that's high enough resolution that you can actually see individual the areas with fairly clear focus here. And so the imagery that was chosen was the National Agriculture Imagery Program, or NAIP. This is that 1 meter spatial resolution aerial imagery that is collected every 3 to 5 years by the US Geologic Survey. And you'll see here that it has 1 meter spatial resolution, and it also has red, green, blue, and NIR. So this allows you to have true color and false color imagery, and you can examine how the landscape changes in a very clear and visual way. So this is 2005, right? And you can already see, especially at site B, where we had that deforestation already occurring, and you can see at site A where we have some deforestation, but the anticipation is that we will see more. So to handle the change detection, so this would be the image differencing approach, they decided to go with Landsat 5. Landsat 5 is one of the Landsat satellites, and so it has a 30-meter spatial resolution. And you can see here that this particular satellite has 7 bands. You can see that it has regions in the blue, green, red, near infrared, and then shortwave infrared. Band 6 here, this is actually thermal. This band is often not used, but it is on the satellite. So for completeness, it's in here. This figure over here, this is the false color composite. So we have the NIR, green, and red bands being used, and you can see that we highlight vegetation in this bright red versus areas of deforestation show up in this sort of pale blue or cyan color. So you can see that even at 30 meters, right, we can still have some visual impact, but not nearly as striking as with the NAIP. So those are the two imagery sets that they use. NAIP for the visual because it's very high resolution, and then Landsat 5 for the image differencing because we have a lot more spectral resolution. So let's go ahead and take a look at what they actually did. So in terms of visual estimation, again, all right, you can look and you can see areas of deforestation. So this would be 2005, and this would be 2008. So this is time 1, this is time 2. And you can see visually here, right, in time 1, site A, right, we had all of this forested area. In time 2, right, you can see that it's been obliterated due to deforestation. And then site B, right, you can see that we've grown back some vegetation. Now again, right, one of the issues with deforestation is that we actually don't have, it typically doesn't come back as forest, especially not right away. So you'll see that we have this sort of lighter brown here. This is areas where we have things like shrubs and grasses beginning to come back, versus site A, again, complete and total deforestation. So even visually, we can already sort of get a really good sense that we have two different approaches and two different types of land change happening here. For completeness, let's also take a look at how we change using the false color from Landsat 5. So again, right, Landsat 5, you can see the exact same sort of changes occurring. You have a major increase in the cyan here, which is deforestation. And at site B, you can see that we have some of these brown areas coming back in, which again are those shrubs and grasses. So let's talk about how they went through the actual mathematical change detection. So they did image differencing, and they did two different types of imagery. The first was to do NDVI, which is something that we've talked about before, which highlights vegetation on a -1 to 1 scale. -1 meaning areas of strong deforestation in this case, and values closer to 1 being areas of strong vegetation growth. So you can see here that the differences here, so this is the difference in NDVI, right? This area here is drastic loss. Right, this area here is drastic gain, because this is the difference. So this is the equation, and this is the difference. So in this case, areas of strong negative are areas where you lost a lot of vegetation. Areas of moderate positivity, these are areas where you gained vegetation. So again, loss and gain, which is exactly what we would expect to see given the different management practices. The next approach that they took is something called PCA. And what PCA does is it is what's called a data dimension reduction technique. And I don't expect you to necessarily understand completely what PCA is. If you're familiar with statistics and other branches of mathematics, maybe you'll already know this. But essentially what PCA does is it tries to essentially rotate the axes of our spectral space so that we have one axis explaining the most amount of information, right? That's why this green line here runs sort of 45 degrees-ish, and you'll see that it runs through the data in the highest, in the longest direction here, and then we can get a second one that's parallel to that runs like that. So again, not super important that you understand what PCA is. Just keep in mind that it is generally a way to include as much information as possible while reducing data volume. But what's more important here is to look at this difference image. So in this case, they took PCA2 and they subtracted the two from each other. And you can see that in this case, right, values that are extremely low, so highly negative values, indicate areas where we lose vegetation, and those are indicated in the reds and the bright yellows. And you can see that site A is very highly delineated here, and then areas of blue tend to indicate areas where we've actually gained vegetation, and you can see that site B here is highlighted there as well. So you can see that we have, again, using this idea of PCA, that you are able to delineate both vegetation loss and vegetation gain. So overall, I think that this case study has really shown that remote sensing can be a very effective management tool, again, because it allows us to have these objective and continuous collection of data that we can go back through and archive for historical change detection. And we've also shown that management practices, in this case deforestation and active management, can really have a major impact on ecosystem change through deforestation or actually reintroducing some of these ecosystems. Okay, so hopefully that makes sense. Hopefully, again, you're able to watch and see the way that I approached this. Again, the three key takeaways here are that I spent a lot of time talking about the remote sensing, both from an image perspective and also from the techniques used. I spent a lot of time looking at the result figures and explaining what they showed and why they showed it. You can see that I spent a little bit of time talking about the environmental aspect in the beginning, and then I brought it back in at the end. And you can see that if you take away all of the explanation portions, the video ran at just over 10 minutes. If you have any questions on the analytical techniques that they used, because you're going to see things that we didn't talk about in class potentially, you're going to see maybe different images, different image sensors. You might see a different technique, like for example, principal component analysis, right? That PCA. You probably haven't seen that before. Right? If you have any questions, please reach out. I would rather have you talk to me before you make your presentation so that you can really hit the things properly than to try to muddle through something you don't understand and end up suffering for it. So as always, if you have any questions, please reach out. Thank you.